Now, this question is interesting, or this example is interesting. It comes from this Wallace book. It's directly lifted off of this book. This example asks us to use the Wien's displacement law to calculate the color temperature, in inverted commas, of the sun. That means you want to find or guess the temperature of the sun, for which the wavelength of maximum solar emission, that maximum wavelength, is observed to be approximately 0.475 micrometer, which is again in the visible light wavelength range. Again, the visible light wavelength range is between 0.4 until 0.7. So this is somewhere in between. And when we look at this graph here, we see that this peak is usually somewhere slightly lower than 0.5, which is about this wavelength range. Right? So we just use that simple equation that comes from Planck's function, derivative of the Planck function, which is the, let's see, the original equation is the maximum wavelength is equals to a constant 2897 divided by temperature in Kelvin. So we have this maximum. So we want to calculate temperature. So the temperature at maximum wavelength is simply 2897 divided by 0.475 micrometer. There is a unit here that cancels micrometer to change to Kelvin. I think the unit should be K micrometer, where you can cancel these two. So that is the unit of this 2897, although it didn't state it there. 6? Whatever. Okay. So just for your information, if this is at 3 decimal points or 3 significant figures, then our answer should be in 3 significant figures. So this is at 4 significant figure. So this one rounds up to Kelvin, because we use this 3 significant figure value. So that is the color temperature of the sun.